Hello, Math 140 students. Welcome back. This is your instructor, Cindy Enrique, and we're going to continue with lecture section 7.4, which is adding and subtracting rational expressions with different denominators. So in this section, the key difference is now you do not have the same denominator. They are different. So that means we're going to do a little bit more work. And whenever you have different denominators, you want to look at the LCD, the least common denominator. So let's look at this. So this first denominator, we have 4 and we have 6. So my LCD is going to be a combination of 4 and 6. So let's think about that for just a little bit. So there's 4, and over here we're going to have 6. So for 4, let me use a different color. I don't really like red. Let's use green. 4. I know that 1 times 4 is equal to 4. 2 times 4 is equal to 8. 3 times 4 is equal to 12. 4 times 4 is equal to 16. Now, when I do this for 6, let's see. 1 times 6 is equal to 6. 2 times 6 is equal to 12. 3 times 6 is equal to 18. And you want to see what the first number that they have in common. So it looks like they both have a 12. So I know that my LCD is going to be 12. So for that first fraction, that negative 3 over 4, I want to make it so my denominator is 12. So what do? I multiply the 4 by 3. And whatever I multiply the denominator, whatever I multiply the denominator by, I multiply the numerator by. So 3 times negative 3 ends up becoming a negative 9. And I'm also going to take that other fraction, that 5, 6, and I want my denominator to be 12. So that 6 I had to multiply by 2. So whatever I do to the denominator, I do to the top as well. So 5 times 2 is 10. So now my two fractions, that negative 3/4 plus 5/6. Well, we know what that's supposed to turn into. It's supposed to turn into a negative 9/12 plus 10/12. So what we end up having is the same denominator. That's exactly what I wanted. So now I have negative 9 plus 10, which is going to give me a positive 1. So I'm going to get my final answer there as 1/12. And of course, you guys can use your calculator and figure it out that way. But I really wanted to show you the thought process because you can't put polynomials into your calculator. You're going to have to come up with the LCD on your own. So that was just a friendly reminder of how to add fractions with different denominators. So now in algebra, we do it just slightly different. So what we do, we want to find the LCD. So we are going to factor the denominator as much as possible. Then we're going to write the product that contains each unique prime factor, the greatest number of times it occurs in the factorization, and then we simplify the product. So let's think about this. We want to find the LCD of the following. So I'm like, okay, LCD. That's all we're doing. We're not adding or subtracting. So here I have a 12x to the 5th, and I want to compare it to that 9 that I have over here. So that way I can at least get the number. So I know that 12 times 1 is equal to 12. 12 times 2 is equal to 24. 12 times 3 is, and here I'm using my calculator, 36. And let's say 12 times 4 is 48. Now let's see what happens with 9s. 9 times 1 is 9. That's not a match. 9 times 2 is equal to 18. 9 times 3 is equal to 27. Still not matching. 9 times 4 is equal to 36. Bingo. Now I've found the LCD of 12 and 9. That is going to be 36. The next thing I want to think about is if I have x to the 5th and x squared. So over here, I have an x to the 5th, and on the opposite, or on the other fraction, I have an x squared. So if I'm choosing between the x to the 5th and the x squared, you take the one that has the most, or is bigger. Or the one that has the most. So that means I'm going to have an x to the 5th as my LCD. So I have my LCD as 36x to the 5th power. Okay. So for number 2, we go on the same way. So we just try to think of, first we deal with the numbers, and then we deal with the exponents. So let's see, I have 10 times 1, which is 10, 10 times 2, which is 20, 10 times 3, which is 30. And that is for my tens. And of course, if I'm comparing that to my 15s, 1 times 15 is 15, 2 times 15 is equal to 30, which is perfect. That's exactly what I need. That's the first number that they share. So the LCD is going to have definitely at least a 30. Now I want to think about the M. And over here, on that denominator, there's no M. Okay, there's 0 of them. So that means I'm definitely going to have an M because it exists in at least one of them. And this one has an N, and that one has an N squared. So which one has the biggest exponent? That's right. N squared has the biggest exponent. So it's bigger. So I'm going to have this as an N squared. So that's going to give me my LCD, 30mn squared. And that's an M. Okay. Now, for number 3, what we're going to have to do is we're going to have to factor first. So I'm going to look at this denominator. When I factor, I see my GCF as 3, so I'm left with a y plus 2. Now, for the next one, I see my GCF as 4, so I'm left with y plus 2. So my LCD, well, if I'm looking at just the numbers, if I have 3 and I have 4, the LCD of 3 and 4 is 12. And I also have my y plus 2. So that's going to be my final answer. For number 4, exact same thing. So I'm going to factor as much as possible and then try to figure out that way. So for number 4, that first denominator, I'm going to have x and x, and I am factoring. The only reason I'm able to do this so quickly is because I've been doing this for a long time. If you guys need to do the AC method until you are quick at it, that's fine. So I know my A value is 1, my B value is -2, and my C value is 1. So A times C is a positive 1, my B value is a -2. So if I have -1 times -1, it multiplies to a positive 1, and it adds to a -2. So that's how I do it using the AC method. And so my next denominator, I have a GCF of a 2x, so I'm left with an x squared minus 1. But remember, that's a difference of squares, so I really have an x plus 1 and an x minus 1. Okay, so now I need to figure out my LCD. Well, for the LCD, I definitely have this 2x. So there is my 2x. And I also need the x plus 1. So I'm going to write down this x plus 1. Now I have to be careful. This is x minus 1, and that's an x minus 1. So notice how this one, I can really write it as x minus 1 squared. Okay? So just making sure that this is the same as x minus 1 squared. So if I'm comparing that x minus 1 squared to the x minus 1 that I have over here, then the x minus 1 squared is the biggest exponent, and there's 2 of those. So that is going to be part of my LCD. Okay? All right. Well, the next couple of problems are my practice problems. So this is where I'm going to press pause, and then you guys work it out and then check your answers. So press pause. Okay, so you guys, hopefully you had enough time to try to work out these problems. I've worked them out myself. It took me a few minutes. So for number 1, that 4 and 6, that LCD is going to be 12. And the biggest exponent is the third one. So it's x to the third. For number 2, I factored out as much as possible. So my LCD is 12, y minus 5. For number 3, it was already factored. So I just had to look and see what my LCD was going to be. So it's 3 times u plus 2 squared. For number 4, I have 3 different terms. The a minus 3 appears once in each, so it appears once in the LCD. The a plus 3 appears once, and the a plus 2 appears once. So all of those go inside my LCD. Okay, and for number 5, only the middle term needs to be factored, so that was x minus 2 and x minus 1. But those were the denominators of the fractions to the left and to the right. So my final LCD is going to be x minus 1 and x minus 2. Okay, so now for our next section. Now that we found the LCD, we are going to add and subtract with different denominators. So now we're actually going to be performing an operation. So the first part was to find the LCD. Now part 2 is to actually combine them together. So the first thing you need to do is identify what the LCD is going to be. So we already know between 4 and 6, my LCD was going to be 12. And I have an x to the third power. I believe that was our first example that we had. So then from here, I'm going to have to think about each fraction differently. So I have my 3 over my 4x squared. So what do I need to multiply 4 to get to 12? So I always want to go back to my LCD. Well, 4 needed to multiply by 3 to get to 12. And whatever I do the bottom, I have to do the top. Okay? And I have an x squared on the bottom, so that means I need an extra x. So on the numerator, I also need an extra x. So that tells me that my numerator is going to be 9x over my 12x cubed. Okay? Now I'm going to think about my other fraction. I have 5 and I have a 6x to the third power. So let's think about what we're going to need. 6 times what gives me 12? 6 times 2 is equal to 12. And I have an x3 and I have an x3. Those match. So that means I know exactly what this fraction is going to be. I'm going to have 10. I just want to use a different color. Here we go. 10, because that's 2 times 5. And 2 times 6 is 12. So I have 12x cubed. So now I'm going to rewrite my fraction. So I have that 9x over 12x cubed plus my 10 over 12x cubed. And now I get to combine, so the same denominator, 12x cubed. And up on top, I have 9x plus 10. And nothing can be factored, there isn't any GCS, there isn't any common terms, so that's as far as I can go. Now, for part 2, or number 2, what I'm going to have to do is I'm going to have to factor before I can come up with a GCF. So when I factor, let's see. So I know that x times x is x squared. To get to 25, that's 5 times 5, and 5 plus 5 is 10. So I know I factored the first one correctly. Now if I'm looking at the second denominator, 6 and 30 have a 6 in common, and an x to the third. That's my GCF. So I'm left with x plus 5. So now I want to identify my least common denominator, which would be a 6x cubed and an x plus 5 squared. And that's to the third power. I'm just going to write that a little bit nicer. X to the 3. There we go. Alright, so now I'm going to work with each fraction individually. So I'm going to have my 7 over my x plus 5 and my x plus 5. So what I need to multiply that by is, it looks like it needs a 6x cubed. So 6x cubed. Whenever I do the bottom, I do to the top. And it's being subtracted by my other fraction. And that other fraction is 17. And I had the, oops, not 16, but 6. 6x cubed x plus 5 to begin with. So what I'm missing here is another x plus 5. So whatever I'm missing, I multiply the top by whatever I'm missing. Okay? So now that I've rewritten it, I'm going to go ahead and do the multiplication in the numerators. So I know that 7 times 6 is equal to 42. So now I have 42x cubed over 6x cubed x plus 5 squared minus, and over here I'm going to have to distribute. So it's 17x, and 17 times 5 is going to be 85 plus 85. And it's my 6x cubed over my x plus 5 squared. So now this is where I'm going to combine everything. So that subtraction here, it's subtract everything. So I have to make sure that I distribute. So please, please, please make sure that you understand that that negative gets distributed to everything. So I have my 42x cubed, and I have a minus 17x and a minus 85. In my denominator, I have a 6x cubed and my x plus 5 squared. And if you want, you can look at that numerator and see if anything can cancel or be factored out, and it cannot. So that is as far as you need to go. So that is going to be my final answer. Okay. Hopefully you are getting the gist of it. So this is where your factoring skills really come into play. You really want to be at the point where you feel comfortable factoring. If you don't feel comfortable factoring, go back to the lectures where we are talking about factoring in Chapter 6. Also, you can email me or a tutor or the Math Success Center, and they can also help you one-on-one. And there's actually a bunch of videos on factoring on websites like Khan Academy. Okay, so for number 3, again, we have to factor the denominator in order to find the LCD. So I'm going to factor the denominator of my first fraction. If I have 2, that's 2 times 1, and if I want the middle to be negative 3, they would both have to be negative. Again, it all comes down to, do you feel comfortable factoring? So here, if I want a positive 1, I'm going to do a positive 2 and a minus 1. And I know that is the correct factoring, only because I've been factoring for a while. So I'm going to have my y plus 2, and I'm going to have my y minus 1, and I also have a y minus 2. So I have 3 terms in my LCD. So for that first fraction, I have y minus 1 to begin with. And in my bottom, I have y minus 2 and y minus 1. So what am I missing from the denominator from my LCD? So I have the y minus 2 and I have the y minus 1, but it looks like I'm missing this y plus 2. So y plus 2. Whatever I'm missing in the denominator, I also write in the numerator. Okay, and then it's subtract my next fraction. So this one, I started off with y plus 2 and a y minus 1, and I had the y plus 2. So what am I missing from the denominator? So I have the y plus 2 and the y minus 1, so I'm missing the y minus 2 factor. And whatever I write on the bottom, I write on the top as well. So now that kind of helps me to figure out what I'm supposed to be doing. So in the numerator, I'm going to multiply that out. So maybe I'll write that over here. So multiply and combine numerator, leave denominator factored. Okay. So up in the numerator, that means I'm going to have to FOIL, which is fine. So if I FOIL this out, I'm going to have y squared plus 2y minus y minus 2. And for right now, I'm just going to write LCD and I'll write it back later. This is just going to help me to just kind of get my numerator stuff going. Now I'm going to FOIL here as well. So I'm going to have my y squared minus my 2y plus 2y minus 4 all over my LCD. So I'm going to see if I can combine anything. So it looks like I have a y squared, and 2y minus y is a positive 1y minus 2 all over my LCD. And it's being subtracted from my green fraction, and I can see in my green fraction that negative 2y and positive 2y, those cancel out. And so I'm left with y squared minus 4 over my LCD. So combining like terms, I'm going to have my y squared minus my 1y minus 2. Don't forget that this is negative, so I have to distribute the negative to both. So it's going to be a negative y squared and a positive 4 all over my LCD. So what's really nice about this is that you can see that the y squares cancel out. So my final answer here, I'm going to have a negative 1y, and I have negative 2 plus 4. So negative 2 plus 4 gives me a positive 2. So I'm going to have y plus 2, y minus 1, and y minus 2. And in the numerator, what I can do is factor out a negative 1. So I'm left with y minus 2 all over my y plus 2, y minus 1, and my y minus 2. So what ends up happening is the y minus 2 cancel, and I'm going to get my final answer as negative 1 over y plus 2 times my y minus 1. So that was a bit of a long problem, but it was doable, okay? So I really want to make sure that I multiply and combine in the numerator and leave the denominator factored as much as possible, okay? And I try to color code it so that the first fraction was blue and the second fraction was green, so you can keep track of kind of like my steps that I'm doing. All right, so for number 4, what's going on with this one is I really want to make sure that you guys see this pattern. So for this fraction, I have 3, and I have my t minus 4, which is in standard form. This is not in standard form, so I want to rewrite in standard form. So I'm going to have this as a negative t plus 4. The t was negative and the 4 was positive. Now the next thing I want to do is I want to factor out a negative. So I'm going to factor out a negative. So I'm going to leave the first fraction alone, 3 over t minus 4. Nothing's happening there. Down at the bottom, I'm factoring out a negative 1, so I can be left with t minus 4. So that's cool. What I ended up doing is I ended up factoring where the denominator is almost the same. And what's really great about this is that -1, I can actually bring that to the top. Bring -1 to numerator. That is the only problem or the only number that can move from the denominator to the numerator without any problems, okay? So I really have 3 over t minus 4 plus -t over my t minus my 4, which gives me 3 minus t over t minus 4. And if I want to rewrite that in standard form, that would be a -t plus 3 over t minus 4. And if you wanted to go a step further, it would be -1 t minus 3 over t minus 4 as my final answer. But really, I would be okay with the step before that. -t plus 3, that's fine. I just like to keep everything with my leading coefficient positive whenever possible. Okay? All right. Well, that is a lot of problems that I did. And the next are practice problems. So hopefully you guys know the gist. Whenever it's practice problems, this is where you press pause and then the answers will be worked out. So press pause. Okay, well, I hope you guys had pressed pause and worked out the practice problems. That is your chance, your opportunity to work them out before you see the answers. So for number 1, I factored and I combined my like terms, and I got my final answer as x minus 5, x minus 3 after things canceled out. For number 2, I found my LCD. After I had factored, I combined like terms and I simplified as much as possible. So here my answer could have been then -2x squared minus 4x plus 4. Or I thought, hey, maybe if I try to factor it, maybe I can cancel some more terms. But it turns out that I wasn't going to be able to cancel anything out. So either answer that is boxed is fine there for number 2. So for number 3, I factored. I have my difference of squares for number 3. And so my final answer there is 4r minus 17 over r plus 3 and r minus 3. Okay, so for number 4, I factored as much as possible. Let's see if I can fit that on one page. Okay, here we go. So for number 4, I factored as much as possible. I multiplied the numerators by what was missing from the LCD. I combined like terms. I had to be careful with distributing that negative sign. It gets distributed to everything in my numerator. I combine like terms and then I factor, and I saw that k plus 3 cancels out on the top and the bottom, so I'm left with -5 over 2k plus 3. Okay, that was number 4. So for number 5, what ends up happening is for that second fraction, I wanted to write it in standard form. So when I rewrote it in standard form, that was that -2x plus 1. Then from there, I'm like, okay, I don't like a negative leading coefficient, so I'm going to factor out that -1. And remember, -1 is the only number that can float up to the numerator. So I floated that up to that numerator. So after I did that, I rewrote it with that -1 up on top. And so I combined my numerators together to give me 4 minus 1x. And I wanted to just write that in standard form just in case, which is a -1x plus 4. And I factored out that -1 just to make sure that nothing else was going to be able to cancel. Okay, that's number 5. For number 6, what I ended up doing is I factored both the denominators. I found my LCD. I multiplied the denominator by what was missing. I saw that subtraction sign. I distributed. But please note that what I did, just to kind of save myself room, I knew that -1w and -9w was going to give me a -10w. So here I just wanted to make sure that you understand that -1 and -9 gave me that -10. Combining those two together gave me -10. So then when I distributed my negative, it's negative times -10, which gave me a +10. And of course I had to distribute that negative to that 9, so I got a negative 9. So when I combined in like terms, I saw that the w squares were going to cancel. And I had negative 9w plus 10w, which gave me a positive 1w. And 14 minus 9 gave me a positive 5. And rewriting the least common denominator, I saw that the w plus 5 canceled. And remember, whenever everything cancels in the numerator, you can always default the numerator to have a 1 in it as a placeholder. So I have as my final answer 1 over w minus 1, w minus 2. Okay? And that is the end of those practice problems. Well, I hope you guys learned, and I hope you guys are enjoying the lectures. And if you have any questions, please contact me, the tutor, or the Math Success Center. I'm here to help you. Thank you.